Assalamualaikum warahmatullahi wabarakatuh. My name is SYAHMI bin HUSSEIN. So our group will present about group project, which is our title is Interpolation. We are from Group 8, Section 5. Okay, this is our group members. First one is me, SYAHMI bin HUSSEIN. Matric number is DE 210109, and the second one is Muhammad AIMAN bin Muhammad YASIN, DE 210097. Then Muhammad Hazieq AHNAF bin ROSNEI, DE 210068, and Raja Syamil Hakimi bin Raja DOLLAH, DE 210064. For introduction, interpolation is a method of estimating values between known data points. This is done by fitting a curve or function to the known data points, and then using the curve or function to estimate the values at the intermediate points. There are two methods that can be used, such as Lagrange interpolation and Newton's divide difference. So basically, Lagrange interpolation is a method of finding a polynomial that pass through a set of given points. The polynomial is called a Lagrange interpolating polynomial for the given points. There are four types of Lagrange interpolation, which is linear approximation, quadratic approximation, cubic approximation, and quadratic approximation. Then, Newton's divide difference is a method of finding a polynomial that passes through a set of given points. It is generalization of Lagrange interpolation, and it has the advantage of being more efficient to compute. The divided difference of a function at a set of points is calculated recursively. Then, methodology. The method we use to solve the problem is Lagrange interpolation, which is the fourth order, which quadratic approximation. And then the second method is Newton's divide difference. We are using manual calculation and MATLAB software simulation to do this project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AIMAN bin Muhammad YASIN, and my matric number is DA210097. Today, our task is make a question based on topic interpolation. So, our question is, Malaysia Energy Static is the lead agency under the purview of the Energy Commission in key economic and energy data in Peninsular Malaysia. The information present is a supplement to the following publication from National Energy Balance 2018. So, this is our data. For the question, approximate the energy consumption in the year 2007 by using suitable Lagrange interpolation and Newton divided difference interpolation. So this is our data that we get from Malaysia Energy Static with the Energy Commission. Okay. For the manual calculation, method number 1, Lagrange interpolation. Okay. The first step, construct the data in tabular form. Okay. The first one, we must create one column for the value of I. We start with 0, 1, 2, 3, 4. Then step number 2, construct the polynomial by using the formula. So for this question, we must use we have 5 point. So the suitable Lagrange interpolation, we use quadratic approximation. So the formula is P4 equal L0 F0 plus L1 F1 plus L2 F2 plus L3 F3 plus L4 F5 F4 L4 F4. Okay. Next, step 3, evaluate F5. So we must put the value of T with 5 and value of T1, T2, T3 and T0 based on the data that we construct from the step 1. So after we calculate the equation, we will get the answer 4844.8750.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hazieq bin ROSNEI. My metric number DE210068. Okay, now I will present about the software calculation, which is I'm using MATLAB to solve the question. Okay, this is the coding for the first method, which is Lagrange interpolation. Okay, what you can see here, the purple text will appear when you run this coding, and then for the first purple text will appear first, and we have to put the independent variable x or the value of x, which is for example 0, 1, 2 and 4, 6. Okay, second, the dependent variable y, which is the value of y, which is the year 2017, 2018, 2020 and 2023, like that. Okay, and for the third purple text, we have to put the value of x, which is we have to put the 20 in the y input. We don't have the 2016, and then we put at the value of x is 2016. Okay, and then this coding will give the required value is fx 2016 is the answer. Okay, from here to here is the Lagrange coefficient coding. After the coding find the Lagrange coefficient, it will continue to find the final result here and will show at here. Okay, we run this coding. Okay, it will appear the first purple text like this. Enter the value of independent variable x in an array. Okay, this is our value of x, 0, 2, 3, 4 and 6. Okay, and then it will appear enter the value of independent variable y in the array. Okay, this is our variable y, 4363, 4495, 4459, 4490, 4662 and the last one 4713. Okay, what is our value of x? We can see here we want the 2017, which means between 4 and 6. 4 and 6 is 2016 for 4, and for 6 is 2018. So between 4 and 6 is 5. So we put the value of 5, and then we will get the answer. Value of 5 is 4844.8750. Okay, that is the same answer what we get from the manual calculation. Next, to prove our manual calculation and software calculation is correct, I will show you the graph of the answer. Okay, this is the coding for the graph to prove our manual calculation and the software calculation for the first method is correct. Okay, first we have to put our x value here, which is 0, 2, 3, 4 and 6, and then the value of y here, and we run the coding. So we have to wait a moment, and it show like this. So what we want is value of x. The value of x is 5 here. So here is the value of x. Okay, here. Which is we get the answer same, not very same, but close with the answer. Okay, here we have the answer is 4846, which is very close with our answer.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Hazieq Hakimi bin DOLLAH. My matric number is DE210065. Okay, now I want to do the manual calculation for second method in interpolation. That was Newton divided difference. Okay, the data that given is all just year and electricity consumption. So we just add the time for T. So for 2012 we use 0 for initial. So 2014 2 because of the gap of the year is 2. So 2015 is 3, 2016 is 4, and 2018 is 6. So we want to find the answer for 2017 here. So the T is 5 because 2016 is 4, 5 and 6. Okay, next just construct the table like this. Okay, for the first Newton divided difference, we use the formula is for F01 equal to F10 minus F00 divided by T1 minus T0. Okay, for data here minus here, divided by 2 minus 0. So we get the answer is 48. Okay, same as before. Just use the formula. So we get the answer is 31. Okay, F21 equal to 172 and F31 equal to 25.5. Okay, for the second Newton divided difference, for F02, use the formula F11 minus by F01 divided by T2 minus T0. So we get the column for T is 1. So we get T2 minus T0. Okay, we get the answer is negative 5.6667. And F12 equal to F70.5 and F22 equal to negative 48.83333. So for next, for the third Newton divided difference, for F03, formula is F12 minus by F02 divided by T3 minus T2. Here we get we kept the column for 2 column, so 4 minus 0. So we get the answer is 19.0417. And F13 equal to negative 29.83333. Okay. Last, for fourth Newton divided difference, we use the formula is F13 minus F03 divided by T4 minus T0. So the answer here, the minus by here, and divide by T4 minus T0, and we get the column 3. So the answer is 6 minus 0, and we get the answer is negative 8.1465. Sorry. Okay, next we construct the table and put the data we get from calculation here. So for the last step is construct the polynomial in Newton. So the formula is here. Okay, we want to find the data for 2017 at T equal to 5. So we just put the T for here is 5. So we just put the data, and then we get the answer is 4,844.8825, also 4,845. So from here we can conclude that the Newton divided difference also same answer we get from Lagrange.
Okay, my name is Mohd ROSNEI. My matric number DE210068. Okay, next is I will present about the second method for software calculation, which is Newton divided difference interpolation with calculation step. Okay, first here we have to put the data of x, which is our data is 0, 2, 3, 4 and 6, and then we put the data of y, which is 4, 3, 6, 3, 4, 4, 5, 9, 4, 4, 9, 0, and 4, 4, 6, 6, 2, and 4, 7, 1, 3. Okay, this is for the number of data point. Okay, This one is for the calculate divided differences, and then this for to coefficient of Newton divided difference polynomial, and then from here to here is for the display the divided difference table. And next we can see here, and this is for the interpolation point. It will generating 100 equal space point. And next is here y for evaluate the polynomial at the interpolation point. And the last part is here for plotting the graph. Okay, we run this command, and we will see the data is exactly same what we do in our manual calculation. And before I show you the manual calculation too, I will show you the data at x at 5 here, same as the previous graph, which is the x is close to value of 5, and the y is close to the value of 4845. Okay, for the table, I will we can see here the table is same from window calculation and the software calculation, which is we will get for F10 is 48, and F1 1 is 31, F12 is 172, and the last for F13 is 25.5. For F10 we will get negative 51667. F11 is F21 is 70.5, and F22 is negative 48.833. Okay, for the F30 is 19.0417. For F31 is negative 29.833, and the last one is F40 is negative 8.1456. Exactly same as the table. Okay, that's all from the software calculation.
For conclusion, between these two methods, which are Lagrange interpolation and Newton divided difference interpolation, so Newton divided difference interpolation is more effective method for approximating a function using a polynomial interpolation. It offers simplicity, computational efficiency, and numerical stability, making it a valuable tool in various numerical analysis and scientific computing application. So that's all from our group. Thank you so much.